In previous lesson, I have discussed about the stack. Today, I will introduce a new concept called queue. So, before start with queue or defining queue, let us take an example. This is a queue in a bank and everybody is waiting to get the service. So, now the first one who is standing in first at first will be serve first, and whoever standing at last will serve last. That means what? That means the order in which the service is going on, that is first in first out, that is called FIFO. And the someone that is point to the first person and the someone is pointing to the last person, that is someone is pointing the first one is called the front side, another is called the last one pointing is called the rear or back side. Let us take another example. So, this is a glass container and we have 4 balls to insert. So, insert first ball, second ball, third ball and fourth ball. So, now we must observe that all the insertion are done from one end and that is called rear, just rear end. So, now you want to delete, or let us say when you take out the ball from the glass container, then what we will do? So, we will take out the ball from other side, that is called front. So, now delete or take out the ball, the first ball first, then second ball and third ball and the fourth ball. So, that means what observation or what you can conclude from that, this conclusion is that once again first in first out, right. So, that means whenever we are defining queue, that is the main thing you have to understand the order, that is called first out, first in and first out. So, now I will define formally the what is queue. The queue is a data structure where insertion is done from one end called rear and deletion is done from other end called front, right. So, this is all about the definition of queue. So, now come to the different operations of queues. So, generally there are 2 basic operations, one is called NQ, that is called insertion, other is called deletion, is called DQ. So, let us take an example of NQ. So, you have inserted the first ball, second ball, third ball, but the end is called rear. So, where from you have inserted? The rear end. So, now that is called NQ or addition operation or insertion operation, whatever you can say. So, the second one is called Dequeue operation, where we have deleted or let us say take out the ball from the container, that is from the another end, that is called the front end. Just take out the ball one after another, that is called Dequeue operations. Apart from these 2 operations, there is another operation also be there. So, that is called display operation. Display means what? What are the elements we have in the queue? We want to display these elements. So, I will discuss later. So, now this is all about the definition and what is queue and what is the understanding of queue. Now, come to different types of queues. So, first there are 4 types of queues. One is called linear queue, number 2 is called the circular queue, number 3 is called priority queue and number 4 is called double ended queue. So, let us discuss one after another. First start with linear queue. So, I have drawn one just diagram in the board, that is basically linear queue diagram, but I want to point out one thing, that whenever you create any kind of data structure, generally we create in the RAM, right. That means RAM means random access memory, what we have primary memory or whatever you can say, right. So, let us start with an example that how we can insert into this linear queue and how we can delete from them and how we can display it. So, before start with the insertion deletion operation, I want to mention 2 pointer already I have discussed. One is called front end, other is called the rear end. Rear end means what? Where from we insert, and front end means what? Where from we delete, right. So, but before discussing about the front and rear, I have to mention one other thing, that initial value of the front and rear must be there, and it is most important, because if we are actually implementing in C or C++, we prefer to implement. So, that is why in C and C++ what happen, the array starts from 0. So, that is why whenever you have a 0th element, that means there must be a one element in the queue or array whatever. So, that is why the convention is that that we start with, if it is the front and rear is -1, that means there will be no element in the queue. So, that is why we initialize front and rear both to -1 initially. Front is -1 and rear is also -1 initially. Once again I repeat. So, why I have taken -1? Because I told you that if you have a 0th element, right, that means one element in the queue, okay. And that is why no element means what? That means is -1, right, the -1 then 0. So, now whenever we insert the first element only, first element in the queue, we have to increment both, not for all. So, I told you earlier, insertion is done through a rear and deletion is done through front. So, that is why, so whenever we insert the first element into the queue, you have to increment both the pointer, the front and rear, right. So, that is why the rear is incremented to 0 and front also incremented to 0 in first case, and then you can insert a character A into this queue, because if there is only one element in the queue and front and rear both the value must be 0, because pointing to a single location. So, now whenever we want to insert the second element, so as you know that I already have discussed that increment should be done through rear. So, that is why we will increment rear first, then we insert the element. Now, we increment rear to 1 and then we insert, then rear to 2, then insert, rear 3, insert, rear 4, insert. That means, what the observation we made from that, that when you insert the first case, the front and rear both must be incremented to 0, then insert. The next, from the next onwards, first increment rear value to 1, then insert, rear value to another 2, then insert, rear value to 3, insert, and rear value to 4, insert. So, this is the maximum size of the queue is in this case is 1, 2, 3, 4, 5. The maximum size of the queue in this case is 5. I assume that the maximum value of the queue is 5. Now, if you want to delete, so I told you the order is first in first out, right. So, that we have to delete the first element over here from front 0 location, but in this case first you delete, then front will be incremented, but in previous case, in insertion case, rear must be incremented first, then you insert. So, but in this case front must be front will be incremented later, first we delete the element, then front come to 1, then delete the element, front come to 2, then delete the element, front comes to 3, then delete the element, front comes to 4, then front comes to 5. So, that means that first we delete the element, then increment the front, delete the element, increment to front, delete the element, increment front, right. In this way we will delete the entire queue, right. So, from this observation, that what from these operations, what you can observe or what you can conclude that in case of deletions, first you delete, then you have to increment front, and apart from that we must conclude the empty conditions of the queue also. So, there are two empty conditions. The first one is that from this value you can observe that the rear value is 4 and the front value is 5. Then what you can do? We can write front is equal to rear plus 1, front is equal to rear plus 1. Apart from that, there is another empty condition, condition number 2, that is front is less than equals to minus 1, front is less than equals to minus 1. So, that means there are two empty conditions to check whether this queue is empty or not. Either you can check for this front is equal to rear plus 1, or you can check by front is less than equals to minus 1. So, that is all about what is a linear queue, because the order is linear. So, in linear order one after another we can insert and delete. but there is a problem in this linear queue. What is the problem, or you can say is a disadvantage of the linear queue? What is the disadvantage? The disadvantage is that suppose in this case now queue is empty, now queue is empty, no one is there in the queue, right. So, that but still we cannot insert. Why? Because the real value is comes to 4, we never come back to 0 to insert or take another elements. So, that means what happened, that if real is increment to a maximum value, so you never come back to the initial point. So, that is the drawback of linear queues. Even if the queue is empty, we cannot insert. That means, in this case what happened, if real is increment to some value, we never come back to a 0 position to take a new elements. That is the drawback of linear queue. So, that is why we are implementing another kind of queue, that is called circular queue. So, in that case, if the real reaches to maximum value, if the first position is empty, it will come back to 0th position. So, that is the concept called circular queue. I will come after that. Now, I will explain what is circular queue, but with an example. Suppose this once again a 5 location 1, 2, 3, 4, 5, right. And similarly, if it is a queue, there must be a front and rear, but this is not actually circular, but I have drawn the figure like a circular queue, but is actually it is linear, right, point to be noted. So, initially front and rear both are -1, and now if I want to insert the first element in the circular queue, the similar thing will happen, that is you have to increment both rear and front to 0. Once again I repeat, whenever you want to insert the first element into circular queue, you have to increment both rear and front to -1 to 0 and then insert. But over here the insertion or incrementing pattern, whenever you are inserting element into the queue and when you are incrementing the rear, the incrementing pattern is different, right. And as well as when you are deleting the element from the queue, the deleting or pattern, or you can say the incrementing of front is different. How it is being incremented? So, first I told you that whenever we insert the first element, then both rear and front must be incremented to 0 and insert this one. Then we increment rear to 1, then insert B, but how it is being incremented? The incrementing pattern is basically like that, the rear equal to rear plus 1 mod max, that means what? That means the max is the size of the maximum size of the queue. Over here max is 5, over here the max is 5. So, now the value of the rear is now 0. Now, we want to insert another element, let us say B over here, then what we do? Put the value 0 to over here, then 0 plus 1 is 1, mod max is 5, I already explained, right. So, the 1 mod 5, what is this value? It comes to 1. So, that is why rear comes to 1 and you insert this B. Similarly, you next case rear is 1 now, then put the value rear over here, 1 plus 1 is 2, 2 mod 5 is 2. So, then we insert the third element into the circular queue. Similarly, we have rear 3, rear 4, right. So, this is the way we can increment. So, but now I will show you how it is possible to insert the new element after the value of 4. Suppose we have deleted this element, right, from this queue. So, now front is incremented to 1, but what is the pattern of incrementing of similar pattern, that is front equal to front plus 1 mod max. This is the similar pattern, right. The front is incrementing in this way in circular queue, front equal to front plus 1 mod max. So, similar way, if the front is 0, then when you deleted the element A, then 0 plus 1 is 1, 1 mod 5 is 1, done. So now I will show you how it is being circular. So, now this location is free, no one is there. So, now I want to insert another element, let us say F into this location, then what we will do? So, first you have to check whether this location is empty or not, right, and the value of rear is what, 4 now. So, if you put the value of 4 over here, then 4 plus 1 is what, 5, 5 mod 5 is what, 0. So, that means it will come back to 0th location, rear will come back to 0th location once again, and we can insert F, and that is the concept of circular queue. That means, if required, if possible, the pointer come back to a 0th location and take another new elements, and if it is once again you delete this element, the rear may come to this location and take the another element. So, that is the concept of circular queue, that actually circumvent of the problem of the linear queue. Okay. However, circular queue has some problem. So, problem is disadvantages. So, for suppose as well as the linear queue also some disadvantages. What are the disadvantages? So, in linear queue as well as the circular queue, always we insert and delete from one end. So, we delete from front and we insert from rear. So, now if you want to delete from rear and front both the side, as well as we can insert from rear and front both the side, then what will happen? So, you have to introduce a new concept called double ended queue. Let us take an example to understand the concept of double ended queue. This is a queue in movie ticket hall. So, where the first one, the first person, that is who is standing first in the queue, so will service for ticket. So, now if somebody has urgency and want to ask a question that when the show will start, he will standing beside the first person and get service. So, that means the both the way the somebody can get the inquiry as well as somebody will get the service as getting a ticket. So, that is the some kind of concept of double ended queue, but that means we are getting service from both the sides. Okay. So, let us take an example of some queue, double ended queue, where we can insert and delete from both the end. Suppose as we have discussed earlier, that front and rear must be initialized to -1, right. So, now if you want to insert first case, front is 0, rear is 0, already I have discussed this one, B, then C, like as linear queue. Right. So, now in this case, so what will happen? We have inserted in the order like FIFO in this way, right. So, now if you want to insert the element at the beginning of that, let us say over here, in double ended queue, that is possible, right. So, that means we can insert from this end also, we can insert from this end also, and when you want to delete, so we can delete directly F also, that is possible in case of double ended queue. So, the most of the cases we are using the only a single ended queue, that is linear queue or circular queue, but it is rarely used, but it has some application we will discuss later. So, then after that there is another kind of queue we have, is called the priority queue. What is a priority queue? So, in case of circular queue or linear queue, we cannot take out the element in sorted order, right. You always take out the element whoever or whichever came first in the queue, right. So, but if you want to take out the element in the sorted order, let us say ascending order or descending order, right. So, then what you will do? What you implement in the queue? So, then the new concept is called the priority queue. Priority queue means what? This is a queue, is basically a linear queue, where the insertion is done in the arbitrary order, but when you delete the element, it should be in the priority based, or let us say in ascending order or descending order. So, there are two type of priority queue once again, it is called ascending priority queue and it is called descending priority queue. In ascending priority queue, you always take out the element in ascending order, and in the descending priority queue, you take out the element in descending order. So, this is the overall concept of what is queue and what is linear queue, what is the drawback of linear queue, what is a circular queue, what is the drawback of circular queue, and then we have double ended queue, right, where you can use this double ended queue, and the last one is the priority queue. This is all about the queue. The next lecture we will start with a linked list. Thank you.